Bismillahirrahmanirrahim. Iyaka na'budu wa iyaka nasta'in. Hello and welcome to Bamus Studiyar. It's me, Kuratulan. Now today we are going to study the second part of organic chemistry, in which we are discussing the functional groups containing carbon, hydrogen and oxygen, and this is the part number 2. Okay, G, we move towards the first functional group, which is carboxylic group, and commonly it is called as carboxylic acid as far as the class name is concerned, and iopacally it is called as alkanoic acid. The functional group is that carbonyl group is there along with OH group. General formula is represented by putting R along with the carboxylic group. So as far as the naming is concerned, as you know that these are the derivatives, and you, in order to get their IUPAC names, what you do is that you have to take help from the name of parents, and the name of parents are alkanes, so you have to eliminate E and add oic acid. The situation becomes alkanoic acid. Then we are having certain examples where we are talking about formic acid, acetic acid, likewise propanic acid, butyric acid and valeric acid. These are named according to the origin from which these are extracted. So when you are having this carboxylic group and instead of having R you are having H, this is called as methanoic acid, and the common name is formic acid for this. As it is having only one carbon, so this is one carbon is called as methane, and you have to eliminate E of methane with oic acid, so it becomes methanoic acid. Secondly, in second situation you are having two carbons over here, so two carbons is ethane, and you have to eliminate E of ethane and it becomes ethanoic acid. So that ethanoic acid is having common name, which is acetic acid. Similarly, we are having the situation of propanoic acid, then butanoic acid and pentanoic acid with 5 number of carbon atoms. And if we go for the common names, they are respectively called as propanic acid, butyric acid and valeric acid. So far we are going for the nomenclature, and for the nomenclature you must keep this thing in your mind that whenever this carboxylic group is present, they are occupying the terminal position. It doesn't matter that it is present on the right side or on the left side of the chain. This carboxylic acid group or the carboxylic group is considered as a king of functional groups. So whenever it is present on the terminal position, the carbon of carbonyl group, they always carry position number 1, and the remaining carbon atoms are taking as a tail of carbon atoms. So when you consider the carboxylic acid in the right side, you have to number it, and you have to number away from the carboxylic group. So this consists of total 6 carbons, so hexane, and E of hexane is replaced with oic acid, so the name becomes hexanoic acid. Similarly, you come across to another example where you are having another substituent at carbon number 4. We can start numbering from this side CH3 and CH where Br is closer 1, but we never recommend it as the C of carbonyl group always carry position number 1. So you have to start numbering from the right side 1, 2, 3, 4, 5, and at 4th you are having a bromine substituent. So it's important in compulsory that you have to locate the position of the substituent at which particular carbon that is actually present, and the name is 4-bromo and total 5 carbons are there, so pentanoic acid. Likewise, we are having another situation where we are having that CH3 methyl group as a substituent in carbon number 3, so the suggested name would be 3-methyl butanoic acid. Let us move towards another group which is considered as queen of functional group, and that is the aldehyde group. As you remember that in carboxylic group you are having COOH, but over here instead of having OH you are simply having that hydrogen atom along with the carbonyl group. So this is the queen of functional group. So their origin or common name is basically aldehydes. You have to put the class name along with the names, and then IUPAC name is that you have to replace E of alkane with Al. So it become alkanal. Function group is COOH, and putting R will show its general formula, and R may be H or it may be any alkyl group. So far we are moving towards its naming. So for the IUPAC naming you have to replace E of alkanes with Al and it becomes alkanal. Now you are having certain examples in front of you where you are seeing the common names and the IUPAC names as well. So the formaldehyde commonly we said formaldehyde because this is originated from formic acid, and ic acid is eliminated with aldehyde. Aldehyde is the class name. So likewise acetic acid, from the acetic acid you have to eliminate ic acid and combine that aldehydic class name and it become acetaldehyde. So this aldehydic group commonly get their names from the name of the acid from which they are originated. That's why I'm saying you that if carboxylic group is the king of functional group, that aldehydic group is the queen of functional group, which get their name from the name of acids and by replacing ic acid with aldehyde. Like previously we are having propanic acid and ic acid is replaced with the aldehyde, so it becomes propanaldehyde. Likewise butyraldehyde and valeraldehyde depending upon the number of carbon atoms. So far when you are moving towards the IUPAC namings, you know that if this is present at the terminal position of the chain and always carry position carbon number 1. Whenever you want to go for the numbering, you have to allot one position to this carbon, and so it becomes methanol because methane is for one carbon, so you have to eliminate E of methane and it becomes methanol. Likewise, in second situation where it is acetaldehyde, you are having two carbons and then ethane is turning into ethanol because that ethanol is representing the presence of aldehydic group, and respectively you are having propanol and butanol along with pentanol with 5 carbon atoms along with aldehydic class or group. Then we come across to the third situation, which is called as ketonic group. Again, in ketonic groups, you are having the presence of carbonyl group and the spare valencies on both sides of carbon. The commonly ketone name is there and as a common name, but when you go for its IUPAC name, you have to eliminate E of alkane with 1. So it becomes alkanone. So we are having the certain example, the general formula that R is same or it might be different, but it never becomes H. R सेम भी हो सकता है, डिफरेंट भी हो सकता है, लेकिन ये आर कभी भी एच नहीं हो सकता. और नेमिंग में मैंने आई हैव ऑलरेडी टोल्ड यू दैट इन नेमिंग्स व्हाट यू डू इज दैट यू हैव टू एलिमिनेट ई of parent hydrocarbon alkane with 1 and it becomes alkanone. In ketonic group, you are having the example where on both sides you are having a smallest R, which is methyl group on either side. So the namings are exactly same because as both R groups are same, both are methyl groups, so they are commonly called as dimethyl ketone, or simply they are commonly known as acetone. The other option is that you have to number the chain. As carbonyl group is present within the chain or the part of the chain, so you have to number it. Numbering for two purposes, because one, it tells you the total number of carbon atom present in that compound, and secondly tells you the presence of functional group on specific, or you can say the position of functional group at specific carbon. So when we number it, we come to know that it composed of 3 carbon atom, and we are having none other than option that this carbonyl group is present in the center. So there is no need to place 2 propanone. It's simply you can say propanone because it's obvious that it lies within a chain. So propanone. And third, we are having another example where ethyl group and methyl group is present on either side of carbonyl group, so it is called as ethyl methyl ketone, because whenever you go for the common names you have to follow the alphabetical orders, but when you go for the IUPAC namings, then the way is different because you have to number the chain, you have to select the longest chain including the functional group, and numbering should be started from that side which give lowest position to the carbonyl group. So you have to number it from left side, and this carbonyl carry second position. So you can call it as butanone. You never call it as 2-butanone because it's obvious that either this carbonyl is on the left hand side or right hand side. अगर ये left पर होता है तभी ये 2 position पे, right से अगर आप count करें तब भी ये 2 position पे आ जाता, तो 2-butanone is enough. Thirdly, we are having another option where the common name is Methyl and propyl ketone, because in the both R groups are different. One is having a smaller R, which is methyl, and another is a bigger group, which is consisting of 3 carbon atoms. So methyl, propyl ketone follow the alphabetical orders. But over here, when you start numbering from the left hand side, it gives second position to carbonyl of ketone group, and it is called as 2, as total number of carbons are 5. So instead of writing pentane, you will go for 2-pentanone. Then we come across to the last functional group, which carry carbon, hydrogen and oxygen. So this is ester group and ester linkage, and over here the point to be noted is that COO, instead of having OH is present in carboxyl group, but COOR is there. Instead of H, you are having R, and R is the alkyl group. So commonly they are called as esters, and when you go for the IUPAC namings, they are called as alkyl alkanoate. Functional group is COOR, and when you put R, you will get its functional groups. And as far as the name is concerned, the situation is different, because the R which is directly attached with O should be named first as alkyl, and the whole other part, which is RCOO, this is called as alkanoate, because over here you have to replace the E of alkane with OH, or you can say ic acid is replaced by 8, because the situation is that all the aldehydes and the esters, they are getting their name, or they are getting the help from the name of king, that is carboxylic group. That's why when you go for aldehydes, you have to replace the ic acid with aldehydes, the name of the class. But when you go for the ester group and the IUPAC naming, over here you have to name it by replacing the ic acid with 8. So we come across to the examples. Over here you are having CH3 group, so commonly the name is methyl, and this whole part is coming from formic acid. So instead of ic acid, you are putting formate. So methyl formate is the common name, but when you go for its IUPAC name, what you do is that methyl, and this whole is carrying only 1 carbon, so this is methane, and E is replaced with OH, so methanoate. So this becomes methyl methanoate. Now we are having another example where, okay, we are having a second example where this is a methyl group CH3, and this whole part is coming from the acetic acid. So this is methyl acetate, but as far as their IUPAC name is concerned, this is methyl, and as 2 carbons are there, so this is ethane, and instead of having E at the end of ethane, we have to place OH, so it becomes methyl. Then we are having another example. This is ethyl group, and this whole part is coming from acetic acid, so ethyl acetate, or IUPACly it is called as ethyl ethanoate. And the last name, where both are carrying the ethyl group on either side of COO, this is called as ethyl, and this 3 carbons is representing the propionic acid, so ic acid is replaced with 8, so ethyl propanoate. While IUPACly it is called as ethyl, and when you count the number of carbons away from this group, 1 2 3, so you will get propanoate. This second lesson is all about that functional groups which contain carbon, hydrogen and oxygen. I try that to make this topic very interesting and very easy for you, so that it can be helpful for you. So inshallah we meet with a new topic where we are discussing those functional groups which containing nitrogen and hydrogen. Till then, from my side, Allah Hafiz.